Okay, so today's lesson we are looking at compounding interest. Overall, today's lesson is not super long. All right, we are still going to be focusing on interest. So in the previous lesson, we looked at simple interest, compounding interest. The main idea, what makes this different from simple, is it accounts for the actual money that's in your account each time it makes the calculation for how much interest you're earning. So day one, if you had $100 and then you made some money, well now, let's say you made $10. So I'll try this out so it's not just me talking. So, let's say you had $100 and you invested that and you made $10. Okay, well now your bank account would say $110. So when your investment goes to calculate how much money you're going to make on your interest, it's going to now use this value as opposed to simple interest, which used this value. Okay, so simple only accounted for the principal. All right, that's all it worried about. That was the previous lesson. Well, compounding is using your current, uses the current. Okay, the current amount. And if you just think about compounding, like it's this word, it's like building on itself, like almost like a snowball, right? Like when a snowball is rolling down a hill, like the snow is like packing on itself. It's like it's constantly building onto itself. It's compounding. It has a compounding effect, right? So yes, compounding will give you way more money in the long run than simple interest would. So to understand or to do the math behind compounding calculations, the actual like formula you use is not super difficult. Okay, so the formula that we're using is just like the the future value formula we had in our exponential unit, where we have the A, which would be like your future value, and then the P is currently what you have, like that's your principal, like that's the thing you're starting with. So this is your initial, and then it's 1 plus your interest rate. Okay, so we've seen that before. And then the N is how many compounding periods. So now the only thing I want to highlight here is the I. You need to change this. You need to calculate this. Calculate this based on compounding periods. Okay, so it changes. Calculate based on compounding. So just know that that value changes. Compounding, sorry. And so does this. Also, this changes too. So calculate as well based on compound, okay? Compound. So whenever you approach a problem, and it gives you your I, your interest rate, and your N, like the number of years that are being applied, just make sure that you are accounting for how many compounding periods are occurring before you actually plug those numbers into your formula, okay? And what do I mean when I say compounding periods? Well, in a question, it will say, you are investing in something and it compounds annually. Okay, so we're always looking at how many compounds happens. We always work on a per year basis. Okay, so something compounds annually, right? This first one right here. Well, annually means that there's only going to be one compounding period that year, right? And so then semi-annually means like 2 times a year. So there's going to be 2 compoundings, right? So like to give you an idea of like what I mean to change your I and your N, right? Like let's say you had this scenario where, well, I mean, you just go I over 2, and then your N here would be whatever time that they give you times 2, right? And then like for example, like take the monthly one to give you the exact same thing. The monthly would be you take whatever interest rate they give you and you would divide it by 12 because it's 12 months in a year. And then you would also adjust the N value, the exponent you're putting on your formula, by taking how many years or whatever they're telling you and timesing that by 12, right? And you would do that for like each one of these, right? So like whatever one is essentially not 1. You don't have to adjust 1 because like I divided by 1 is still I, or T divided times I is still T. All right. The only ones I want to add on here, all right, that this is forgetting, is weekly. So if you weekly, so there is 52 weeks in a year, and then bi-weekly, right? Like paychecks, right? You'll see this a lot, bi-weekly. And how many bi-weeklies are in the year? Well, it's just half of weeks, right? So there'd be 26 bi-weeks in a year, right? So just know those two terms as well, because you'll see those. All right. So as I said, it's a pretty short lesson, all right? Like the main takeaway from this lesson is just understanding how to apply this formula and just simply calculating your I and your N value. So suppose a principal of $2,500 is invested at an annual rate of 5% for 5 years. So just knowing how to read this problem and just take away a key piece of information, all right? So suppose a principal of $2,500, okay, so in this problem right here, I mean, for A, B, C, and D, our principal is always going to be $2,500. So that is what we are starting with. The P value in our formula is 2,500. It is invested at a rate of 5%. Okay, so this is your I value. So annual rate, right? So annual rate says that there are actually I'll tell you. Cover the minimum invested. Yeah. So annual rate, so the I value is 5%. And for 5 years, this tells you right here that T is 5. Okay? So calculate the amount of investment at maturity. So in this case, there is the compounding periods. There are your number of compounding periods. Compounding periods is 1, okay? And the reason I know it's 1 is because at no point here did it say semi-annually. It didn't say anything like quarterly, okay? It's just saying that you just have this interest rate, it compounds annually, so I mean every year that goes by, it's just going to compound. It's going to make your new adjustment, okay? So how many compounds happen in 1 year? If it happens every 1 year, just one time. So we apply our formula, all right? So your future amount, your A, right? And by the way, you were given these formulas, so don't worry about memorizing them. Just know how to read a question and be able to pull where the variables come from. So A is equal to P 1 plus I to the power of N. So A, calculate the amount of the investment at maturity. Okay, so again, from our previous lesson, this is what happens at the end. And the amount is our A, is our future value. So we're looking for A. So our principal is 2,500. And then we have 1 plus our interest rate. So if I is 5%, that's the same thing as 0.05, because again, you turn it into a decimal. So 0.05. And then all of that is being put to the power of n. And in this case, n is equal to 1 times their t value, right? So that's 1 times 5, or 5. So 5. Okay, so I'll just write out one more step. 2,500. Put that I value together. So you would do this math first, right? So that's 1.05 to the power of 5. And now if we calculate that, we are essentially going 1.05 to the power of 5. And then you multiply that by 2,500. And again, we're working with money, so make sure you're putting it into 2 decimal places, okay? So your amount at the end of your at maturity, so after 5 years, you would have $3,190.70 after rounding, okay? Part B. Oh, here, let me box that off so we know where our answer is. Here we go. What would the amount be if the interest was compounded semi-annually? Okay, so again, if you need to, just go scroll up and be like, okay, well, what does semi-annually mean? Like how many compounds? And this you actually do need to know, okay? So I'm not going to tell you what semi-annually means. You do need to know that, right? And that's just also for your sake, genuinely. Like if you go to a bank and in the real world, like you just need to know these values when somebody's talking to you. So it is just good information to have. So semi-annually, just for now, I'll show you, right? Semi means 2 compounding per year, okay? So you just read across. There's 2 compounding per year. So what would the amount be? So again, we are calculating our A value. So what would the amount? This question again is asking for the A, but the main thing is now we're compounding it semi-annually. So let's see how this impacts our amounts. So because it's semi-annually, we have to adjust 2 things, right? Both the I and the n value. So in this case, the I that we are using is our percentage, 0.05%, right? Or 5%, which is 0.05, dividing that by 2, because it's semi-annually, right? This means 2, right? So that would give us an interest rate of 0.025. And then your n value is how many compounding happens. Well, your investment is going for 5 years, so there is 5 years, and you are multiplying that by how many compounding happened in 5 years. So if this is ticking away for 5 years, that means there is going to be 10 compounding periods, okay? So now if we plug those new values into our formula, we have A is equal to 2,500, 1 plus now our new interest rate, this 0.025, and that is all being put to now the power of 10, okay? So let's go through our math. So 1.025 to the power of 10, now that being multiplied by 2,500. Your A is going to be 3,221 cents. So again, 2 decimal places because you're dealing with money. Okay, I know we're going to conclude what happens in part D, but I just want to pause for a second and just have you make your own conclusion as we go. Look at the money here and look at the money here. And just be like, okay, what was the only thing that we changed? All right, so in the first one we compounded annually, the second one we compounded semi-annually. Which one makes you more money? So let's do it again. This for quarterly this time. So again, because quarterly we need to adjust 2 properties when you're doing compound. Your I is now going to be the percentage that they give you. So it's going to be your 5% in a decimal, so 0.05. So again, this is 5%. This is 5%, right? Divide that. Actually, make that 5 more clear. 5. Divide that by 4 quarters, okay? So that would be 5 divided by 4, yeah. 0.0125. Okay, you also need to adjust your n. So your n is still 5 years you have this investment in there, but now there are 4 compounding periods. So this would have 20 compounding periods across your 5 years of investment. So let's do our A again. So your A is 2,500. Multiplying that by 1 plus your interest rate. So our interest rate is now 0.0125. But there are 20. It's put to the power of 20. Okay? So just keep in mind your I and your N, okay? For quarters, like how this adjusts. That's the main takeaway from this lesson today, okay? So then your $2,500 is now being multiplied by 1.0125, and that's being put to the power of 20. And if we just put that in our calculator, your A value is going to be, so 1.0125 to the power of 20, times that by 2,500, we get $3,205.09 after rounding. So there is your amount, and I forgot to box my previous answer. So part D, what is happening to the amount of the investment as the number of compounding periods increases? Well, can you see the relationship? We had 1 compound, we only made 3,190. We made 2 compounding periods, so now twice in a year it compounded. Well, you actually made $10 more. And then you had 4 compounds in a year, and you made $5 more than your semi-annual, or $15 more than your one time a year. So generally speaking, like if you were just, most basic, as compounding increases, or compounding periods, I should say, as compounding periods increase, well, final amount increases. And essentially using my snowball analogy, right? Like, so you have the snowball rolling down a hill. Essentially, when you increase the amount of compounding periods, it just increases the amount of time that you're packing snow onto that snowball. So if more snow is going on the snowball, like more times you're packing snow on it, well then that snowball is gonna be bigger because you're putting more snow on it each time, right? So as compounding periods increase, final amount increases. Right? There's this direct relationship between the two. Okay, go into an example 2. Lucia borrows $4,000 for a car at an interest rate of 8.75% per year, compounded annually. If he plans, if he, I should say she, if she plans to pay back the loan in 6 years, how much will she owe? Okay, so if $4,000 was taken out, well, what is that $4,000? Again, you're using this formula. A is equal to P 1 plus I to the power of n. So just you're looking at this and being like, okay, well, what piece of information do I have? So Lucia borrows $4,000. Well, that $4,000 right there, that's your P. Your P is your principal. It's what you started with the whole problem with. It's what initially is there. Well, there's an interest rate of 8.75%. Okay, so first, let's put that into a decimal percentage. So that's 8.75%. But then we need to put that into actual decimal, right? So then your I is actually 8.75% divided by 100, right? Because you're putting it into a decimal. So that's 0.0875. Okay, compounded annually. Well, what that means is you have one compound period. One compound period. So if she plans to pay back the loan in 6 years, well, in 6 years, there is your time, right? So remember, this n right up top here is n is equal to your time multiplied by your compound periods. So in this case, if t is equal to 6, well then n is equal to 6, your time, multiplied by 1, your number of compound periods. So then n is just equal to 6. So plugging it into a formula, how much will she owe? Well, how much, right? Like that whole question of saying, like, tell me the future amount. That's your A. So A is equal to your principal, $4,000, multiplying by 1 plus your interest rate. So in this case, again, this is being divided by 1 because we have one compound period, right? So the I is still just 0.0875. Nothing changes there because you have to adjust both your interest and your n value. So 0.0875, nothing changes there because it's going annually. And then to the power of 6. So then if you do your math, right, make sure you're cleaning up the bracket first. So it's 1 plus your interest because you have to make sure you do this first, right, before you put it on your calculator. So 1.0875 to the power of 6. And you multiply that by 4,000, and you will get a future amount of $6,616.61. Okay, so how much will she owe? Well, she would owe this amount, right? So to borrow $4,000, you actually have to give back $6,600, right? So there is what we call in the financial world a cost to borrow, right? Nobody's just going to give you $4,000 and to no advantage to them, right? The bank wants to make money, so in this case, they would have made $2,600, right, for giving you $4,000, and that's why banks are a very successful business, right? Yeah, having a mortgage to them, you make a lot of money. So B, how much interest will he have paid, or she? Sorry, will she have paid? All right, so in this case, I mean, I kind of did the math for you. I already answered B, but if you borrowed $4,000, your interest is like the only thing that is making money or changing money is the interest, right? So pretty much the way you got to think about it is whenever you're calculating interest is what was the amount of money that changed in this case? Well, if you started with $4,000, right, like that was the only money that was in this problem, and then you finished with 6,616 and 61 cents, right? Well, how much of an increase is that, right? So subtract those two, and you would get, well, $2,616.61 is your difference, right? So this is your interest, because the only thing that is making money or losing money is the interest. So how much interest will she have paid? $22,616.61. Right? So it's always your A minus your P, right? Like that's what interest is, equals I. Your future amount minus your principal. Okay. Example 3. HEMA can invest $10,000 into an account that pays 9.2% compounded semi-annually, or in another account that pays 8.8% compounded daily. She plans to hold the investment for 4 years. Which account is the better investment, and by how much? Okay, so let's kind of just make it organize a little. So HEMA can invest $10,000 into an account that pays 9.2% annually. So let's call this semi-annual account. Let's call this account A, okay, just so we can like do our math under A. And in another account that pays 8.8%. So we'll call this account B, okay? So here, I'll underline it different too, so you can visually see a different account. 8.8. There you go. We'll call that one B. Compounded daily. She plans to hold investment for 4 years. Okay, so there is your time. That is how long we are analyzing this problem for. So T is equal to 4. Which account is a better investment? So what we're going to do is we're going to calculate A for both of them, and we're going to count like our future value, and we're going to account for like compare the two final amounts, right? So in account A, your principal is still the same. I'm going to give myself some room here because I know I'm going to write a lot. Your principal is the same still. So your principal is 10,000, right? Like from right here. All right. Well, again, think about the formula you need. You know, you have A is equal to P1 plus I to the power of n. So you got to think, where do I get these values from? So we need an I. Well, the I is 9.2%. But your I in this case is 9.2%, so that's 0.092. But you have to divide it by how many compound periods are there. Well, in this case, semi-annually tells you that there are 2 compounds. 2 compounds. So in this case, we are going 0.092 divided by 2. So we get an interest rate of 0.092, divide that by 2. 0.046. Okay, also need to adjust your n. So your n in this case is going to be, well, we're holding it for 4 years, so there is a t of 4. So in this case we have 4 years multiplying by 2 compounds. So that would give us 8. We have a final amount of, I'll do it in pink, 8. So then your A value, your formula, is 10,000, 1 plus 0.046, right? Because you're putting this value in, your adjusted I value, to the power of 8. You're putting in this value right here. I'm going to cross lines. And that goes there. Okay. So we have 10,000, 1.046 to the power of 8. And now just plug in your calculator, 1.046 to the power of 8. And times it by 10,000. So if we had an interest rate of 9.2% compounded semi-annually, we would make 14,330 and 24 cents. Okay, so notice how this problem has 2 different interest rates, but also 2 different compounds. So it's kind of interesting because it's like, okay, well, which one is actually the better one? And on the top of my head, I actually don't know. So there we go. So account A gives you a higher interest, but lower compounds, right? So account B has a lower interest, but it has more compounding periods. So let's see which one actually has a greater effect, right? So in this case, account B, it compounds daily. Actually, that one's probably going to be the higher if I just think about it. Compounding daily is quite often. So that means your compounding periods here, there are going to be 365 compounds. 365 compounds. Well, let's figure out, and let's see how the values change, right? So in this case, your P is still 10,000. You're not changing how much money you're putting into it. But your I is adjusted. Your I is your 8.8%, so 0.088. And you divide that by 365, right? Because that's how many compound periods there are. So 0.088 divided by 365. So I have a value of 2.41 times 10 to the negative 4 on my calculator. But if you didn't know scientific notation, this is the same thing as me saying 0.123241. Okay, those are equivalent to each other. So just know which one your calculator gives you. And then your N in this case, your N is still the 4 years multiplied by the 365. So that is going to give you 4 times 365, 1460. So if we plug in our formula, our future amount, A is equal to your principal, 10,000, multiplied by 1 plus, and I'll use the decimal one, 0.000241, okay? All to the power of 1460. So I'm sure you already know how to put those 1 plus that decimal together, so I'm not going to do that. 23241, all to the power of 1460, times that by 10,000. 1, 2, 3. So in this case, you make 14,216 and 49 cents. Oh, I was actually wrong. Wow, that's interesting. So higher interest rate matters more. Okay, well in this case, if you look at it, you made more money in account A, right? So therefore, account A. I'll do it in blue because that's what we did. Therefore, account A made more money. And it says by how much? Well, let's subtract those two. So then A minus B, right? So we have 14,330.24, and we're going to subtract 14,216.49, and what does that give us? So 14,330.24 subtract 14,216.49, we make a difference of $113.75. So account A made more money by 113 made $113. Yeah, we made more than B. There we go. Cool. Last question. Marco wishes to have $18,500 to buy a car in 4 years. All right, so this is your principal. Your P is 18,000. That's your P. 18,500 in 4 years. 4 years. Here's your T. He has $12,000 now. Oh, sorry, wishes to have. Oh, sorry, I should have just read the question actually. So, Marco wishes to have 18,500 to buy a car in 4 years. He has 12,000 now. If he invests his money into a bond that earns 7.5% compounded weekly, will he have enough money to achieve his goal? Okay, so will he have enough money? So will he have enough money? So this means go through your scenario and calculate A, right? And then what he is saying is compare this value to this. So this whole question is saying compare A to 18,500 and saying, do we have more or less, okay? So he has 12,000 now, right? That's why I kind of adjusted my principal. So now this is your principal. P is 12,000. All right. Still 4 years. So this was your T. T is 4. If you invest some money into a bond that earns 7.5% compounded weekly, okay, so compounding weekly means there are going to be 52 compounds, right? 52 compounds in a year. So that means we need to adjust all of our I and our N. So your P is still 12,000, but your I is 7.5%, so 0.75. Divide that by your 52 compound periods. So that's going to give you, so 0.075, divide that by 52. In decimal format, that's going to be 0.00144. Oops, sorry, 144. Your N is 4 years, multiplying that by your 52 compounds. So 4 times 52, that's going to be 208 compounds. So now just put it in your formula. A is equal to your principal, 12,000, multiplying by 1 plus the interest rate, your 0.00144, all to the power of 208. Let's see what we get. 1.00144 to the power of 208, times that by 12,000, and we'd have $16,187.04. So if this is how long Marco put the money in, well, no, he would not be able to achieve his goal because that is less. This is less than 18,500. So will he have enough money? Therefore, no, he will not have enough. No, he will not have enough money. Okay, and that is today's lesson, and there is our homework at the bottom. Bye for now.